Assalamualaikum warahmatullahi wabarakatuh. I am ROKIAH binti OTHMAN from Faculty of Civil Engineering and Earth Resources, University Malaysia Pahang. Welcome to UMP MOOC-High-Rise Building Material. Today we're going to continue our topics about high performance of concrete. So the expected outcome of today, students should be able to explain the high performance of concrete. Previously, we have studied about the properties of material making concrete, and now what is high performance concrete? HPC is a concrete which meets special performance and uniformity requirements that cannot be always achieved by using only the conventional material and normal mixing, placing and curing practice. The performance requirement may involve enhancements of placement and compaction without segregation, and long-term mechanical properties, early age strength, toughness, volume stability, and service life. Concrete possessing many of these characteristics often achieve high strength, but high strength may not necessarily be of high performance. So today we're going to cover what is the characteristic of high performance, material selection for the high performance concrete, the mixed proportion, the properties of fresh and hardened concrete, the concrete handling, and the last one is applications of high performance concrete for the high-rise building material. A higher demand for high-rise building worldwide, relatively recent advances in concrete technology and development in construction method has led to an increasing number of reinforced concrete, super tall and mega tall high-rise building being constructed. Special attention is required when making use of concrete in this building. Stringent performance requirements, careful design of mixes required, and numerous construction considerations that must be taken account of. High performance concrete is a crucial part of the viability of high-rise building, even more so for super tall and mega tall buildings, not only structurally but economically too. The advance in strength, stiffness, pumpability, and high early edge strength of high performance concrete, coupled with prefabricated reinforcement cage and the significant developments of slip and climb formward technology, allow the construction of compact reinforced concrete RC structures to progress at 2 to 3 floors per week. Properly designed RC is therefore becoming more viable in terms of construction speed than structural steel. So, what is the characteristics should be stated? So, the characteristic of high performance as follows. Number one, the high performance should have high early strength and continuous strength development. Number two, high strength. Number three, low heat of hydration. Number four, high workability and control slump. Number five, low water binding ratio. Number six, low blending and plastic shrinkage. Number seven, high modulus of elasticity. Number eight, high abrasion resistance. Number nine, high durability and long life in severe environments. Number 10, low permeability and diffusions. And number 11, high resistance to chemical attack. So therefore, you can see from the figure, from the photo, the required durability characteristics are governed by the applications of concrete and by conditions expected to be accounted at all the time placement. These characteristics should be listed as follows. So the high performance should be resistant to the environment. So it will delay for the deteriorations compared to the previous concrete. So this is the performance requirement should be achieved for the high performance concrete. For example, number one, composite strength should be 70 megapascal. And then number two, very early strength. For example, 70.5 megapascal. And then number three, early strength for 24 hours is 35 megapascal. Number four, high degree of impermeability to prevent ingress of water or moisture. Number five, high resistance to sulfur attack. Number six, smooth fracture surface. Number seven, absence of microcracking. Number eight, high level of corrosion resistance. Number nine, high chemical resistivity. And number 10, high resistance to abrasion, erosions and cavitation. So how to achieve that kinds of characteristic? So we need to properly select the material. So the main ingredients of high performance concrete are almost the same with conventional concrete: cement, fine aggregate, coarse aggregate, water, and mineral admixture. So we need to use suitable fine filler or pozolymer material, and also we need to use chemical admixture such as plasticizer, super plasticizer, retarder, and acrylic agent. So from this table, you can see the material that should be used for the high performance and why we need to use the material. Next, the important thing is the mix proportion. So here we need to design mixed designs of high performance concrete as follow. The water binder ratio should be as less as possible, preferably 0.3 or below. The workability of concrete mix should be good compaction because of use of super plasticizer, and the transition zone between aggregate and cement paste should be strengthened by using silicone fuel. So after we have designed the mix, design concrete, then we can mix. So during the mixing stage, so we have fresh concrete. So what is the properties of fresh concrete? So here, under the fresh concrete, we have workability, consistency, segregations, and bleeding. So the strength and durability of concrete of a given mixed formation is very dependent on the degree of its compaction of fresh concrete. It is vital that the consistency of the mix such that concrete can be transported, placed and finished sufficiently early to achieve higher strength and durability. So what is the properties of fresh concrete? The important is workability. Workability should measure at least 3 separate concrete properties. Number 1, compatibility. Why we need to measure the compatibility? The easy with which concrete can be compacted and avoid remove. Number 2, movability. The easy with which concrete can flow into form around steel and be remodeled. And the last one is stability. Ability of concrete to maintain its uniformity. The ability for concrete to remain a stable, coherent, homogeneous mass during handling and vibration without consistent segregating. So the common workability tests are done by using slump test, flow table test, VB test, and compacting factor test. Workability for adequate flow through congested rebar cages is largely made by the requirement for pumping of the concrete. So the change in rheology after pumping should, however, be accounted for. The use of virtual self-compacting pumpable concrete result in lateral pressure on formwork, and so formwork should be sufficiently strong. So the figure shows the improper placing concrete into the formwork. What is the significance of fresh concrete? The first 48 hours are very important for the performance of the concrete structure. It controls the long-term behavior, influence of ultimate strength, elastic modulus, grip and durability. Number 1, consistency concrete. What is the consistency of concrete? Consistency or fluidity of concrete is an important component of workability and refer in a way to the wetness of the concrete. However, it should not be assumed that the wetter the mix or higher workability, the more workable it is. If mix is too wet, segregation may occur with resulting honeycomb, excessive bleeding, and sand striking on the formed surfaces. On the other hand, if a mix is too dry, it may be difficult to place and compact, and segregation may occur because of lack of cohesiveness and plasticity of the paste. Therefore, 3 ways to determine consistencies of fresh concrete. Number 1, we can have slump test. Number 2, flow table test. Number 3, ball penetration test. So what is slump test? A slump test is a method used to determine the consistencies of concrete. The consistency stiffness indicates how much water has been used in the mix. So a slump is a measurement of concrete workability or fluidity. So the figure shows the slump cone or frustum of a cone with height 300 millimeter and the base is 200 millimeter in diameter and it has smaller opening at the top of 100 millimeter. So the tamping is used to compact the mix. So you can see here the procedure to conduct slump test. There is concrete should be fit in 3 layers and each layer tempered 25 times with rounded and straight rod. The mold are held firmly against its base and immediately but slow lifted it vertically. The mold is placed beside the concrete specimen and the decrease in height of slump is measured. So from the figure, you can see that the height and shape of slump obtained varies from one mix to another depending on the mix workability. So we have 3 types of slump. We have collet slumps, we have shear slump, and we have through slump. So which type of slump is good? Number 1, through slump. The concrete after the test gives slump evenly all around. So we should get the through slump for our concrete mix. And number 2, shear slump. One half of the cone may slide down the other. Often indicates a lack of cohesion and it tends to occur in harsh mix or mix prone to segregation. It may indicate that the concrete is unsuitable for placement. So we need to redo our concrete mix design. And the third is collet slump. Slump may collapse because of very wet concrete. It indicates a lean, harsh or more likely a very wet mix. What is a slump loss? It defined as the loss of fluidity in fresh concrete with time, which due to hydration or cement, losing of water. So can be delayed or retarded by admixture. So another test is flow table test. So flow table test give the consistency of the concrete mix. So here we have the flow percentage is diameter of flow minus by the base diameter and divide by the base diameter multiplied by 100. So another test is, another method used to measure the consistency is by the ball penetration test. And also, there is the flow table test to measure the ability of mortar instead of concrete. So the workability of concrete, it can be defined as the properties of fresh concrete, which is indicated by the amount of useful internal work required to fully compact the concrete without bleeding or segregation in the finished product. Concrete is said to be workable when it is easily placed and compacted homogeneously, means without bleeding or segregation. Unworkable concrete needs more work or effort to be compacted in place. Also, honeycomb or pockets may also be visible in finished product. What is the factors affect the workability? So now we have several factors. Number 1, water content in the concrete mix. Number 2, amount of cement and its properties. Number 3, aggregate gradings. Number 4, nature of aggregate particle, which is the aggregate property, shape, surface texture and porosity. And number 5 is temperature of the concrete mix. Number 6, humidity of the environment and mode of compaction, and method of placement and method of transmission of concrete. So how the water content will affect the workability? Higher water content would increase workability, leading to increased void in concrete, finally reduce its strength. And then too high workability result in segregation and tube bleeding. Finer particles require higher amount of water to be workable in contrast to coarse aggregate. This is because fine particles have higher specific surface area compared to the less fine. So this figure shows the higher water content leads to higher workability of concrete, and also the next figure shows lower water content leads to concrete with lower workability. But you must bear in mind, if we are using the super plasticizer, we can have the higher workability. So the next factor will affect the workability is aggregate. Number one is amount of aggregate, and then relative proportions of fine and coarse aggregate, and shape and texture of aggregate particles. So for a constant water cement ratio, an increase in the aggregate and cement ratio will decrease workability. So lead in fine aggregate use would result in harsh mix that has low workability. So the more nearly spherical aggregate would result in more workable mix compared to mix with angular aggregate. So we have discussed in the aggregate topic previously. So this is due partly to that fact spherical particle will act as a ball bearing, while angular one have more mechanical interlock. Smooth particle will tend to be more workable than rough one. Porous aggregate would lower concrete workability since it will absorb the water used. Next factor is time and temperature. How time and temperature will affect the workability? With higher temperatures would result in higher evaporation rate and hydration rate, hence reduce the workability. Fresh concrete loses workability with time, mainly because of the loss of moisture due to evaporation. Loss of workability varies with the type of cement, the concrete mix proportions, the initial workability, and the temperature of aggregate. And the next factor is cement characteristic. For a constant water cement ratio, the increased fineness of type 3 high early strength cement would produce mix with lower workability compared to light fine one. This is because it possesses higher specific surface area. And then the next factor is admixture. Additions of air alternate admixture and plasticizer will increase workability. However, additions of polyolinic materials such as slag, fly ash, and cement replacement would reduce workability. So how to improve the workability? So we can increase water cement ratio, increase size of aggregate, use well-rounded and smooth aggregate instead of irregular shape, increase the mixing time, increase the mixing temperature, use non-porous and saturated aggregate with additions of air alternate mixture. So the next test is compacting factor. What is the compacting factor? This test gives the behavior of fresh concrete under the action of external forces. So the apparatus used for this test consists of two inverted cone shape hoppers and the cylindrical container. The procedure to conduct slump test have four. Number one, the top hopper is filled with a representative sample of the concrete, and then when completely filled, a hinge door at the bottom is released and the concrete allowed to fall into the second hopper. Then the concrete is similarly released from the second hopper and falls into the cylindrical container. Surplus concrete is stuck off by currently working to stay float from the outside to the center. So the contents of the cylinder are then weighed to the nearest 10 gram, giving the weight of partially compacted concrete. And then the cylinder is then refilled from the sand in layer approximately 50 mm thick, the layer being rammed to obtain full compaction. So the top surface again struck level off with the top of the cylinder, and the weight the concrete container again determined, which is known as the weight of fully compacted concrete. So the compacting factor can be measured. The compacting factor is the ratio of the weight of partially compacted concrete to the weight of fully compacted concrete. So normally it ranges between 0.8 to 0.92. The table describes the workability of the concrete. The next time is VB time. What is the VB time? It is based on measuring the time, which is called VB time, needed to transfer the shape of a concrete mix from a flattened cone to a cylinder. This shape are standardized by the apparatus of this test by vibrating and compacting the mix. The more VB time needed, the less workable the mix is. This method is very useful for the stiff mix. So what is significance of VB time? So the data measure the properties of concrete under vibration. Most suitable test for determine difference in consistency of very dry mix. This test determine the time required to achieve compaction, which is related to the total work done. Data obtained in the form time in seconds, known as a VB time. How to measure VB time? So, number one, the time required for the shape of concrete to change from slump cone shape to cylindrical shape in seconds is known as watt degree. Number two, this method is very suitable for very dry concrete whose slump value cannot be measured by slump test. But the vibration is too vigorous for concrete with slump greater than about 50 meter. The test failed if VB time is less than 5 seconds, and the test must be created when no collapse or shear slump is concrete. So the figure shows the VB time test, which is number one is filling in the fresh concrete, and number two for ready for vibrating. Okay, the next properties of the fresh concrete is segregation. So what is the segregation? Segregation is when the coarse and fine aggregate and cement paste become separated. Segregation may happen when the concrete is mixed, transported, placed and compacted. So this segregation makes the concrete become weaker, less durable, and will leave a poor surface finish. So what is the factors contributing to the increased segregation? Number one, larger maximum particle size, which means over 25 mm, and proportions of the large particle. Number two, the high specific gravity of the coarse aggregate compared to the fine aggregate. Number three, decreased amount of fines, such as sand or cement. And then, number four, changes in the particle shape away from smooth, well-rounded particles to odd shape or rough particles. And then, mix are too wet or too dry. And then, the last one is improper handling and placing method. What is segregation? So, segregation can be defined as separations of the component of fresh concrete resulting in a non-uniform mix. So, this figure shows the effect of segregation to the harder concrete. So, we can see the poor surface. So, how to avoid segregation? So, number one, we need to check the concrete is not too wet or too dry. Make sure the concrete is properly mixed. It is important that the concrete is mixed at the correct speed in the transit mixer for at least 2 minutes immediately try to discharge. And then the concrete should be placed as soon as possible. When transporting the mix, load carefully and always pour new concrete into the face of concrete already in place. And then when compacted with a poker vibrator, be sure to use it carefully. So, if placing concrete straight from a truck, pour vertically and never let the concrete fall more than 1.5 meters. So, what is the concrete bleeding? Concrete bleeding is one of the properties for the fresh concrete. So, concrete bleeding means upward movements of water after concrete has been consolidated but before it has set. Figure shows the concrete bleeding. So, bleeding is a special form of segregation. Water on the concrete surface is the most common manifestation of bleeding. Sometimes, along with the water, certain quantity of cement also comes to the surface. The formations of cement paste at the surface due to the actions of bleeding water that brought the cement to concrete surface is also known as lichens. So, what is the method to reduce concrete bleeding? Number one, reduce water content while maintaining an acceptable workability. Number two, increase cement fineness. Number three, use pozzolans or other finely divided mineral admixture. Number four, increase the rate of hydration of cement by using cement with high alkali content. And number six, through air entrapment. And the last one is proper compaction. So, the rest of the slide, you will refer about the concrete bleeding. This is the effect of excessive bleeding in deep section, bleeding problems and flat work, and then how to control concrete bleeding.